In the last lesson, you had a review of angles, and you looked at acute and obtuse and right angles and straight angles. And today we're going to take a look at different angle relationships. And we're going to start by talking about angles that are called adjacent. Adjacent angles are angles that share a common ray. They have to share a common ray. They also share a common vertex, okay, but they do not share no common interior points. Okay. Adjacent angles are angles that share a common ray and a common vertex, but they do not share any common interior points. And so we're going to look at an example of angles that are adjacent and compare that to angles that are not adjacent so you can see those different qualities. So let's start with the picture on the left. Okay, looking at this picture, okay, we're going to look at angle ABC, which if I follow the letters, ABC is this angle right here. And then we're going to look at angle CBD, which is this angle right here, angle CBD. What I'm going to do, I'm going to take a colored pencil, and you can feel free to do this also. I'm going to use a green colored pencil, and I'm going to trace angle ABC in green. Okay, here's angle ABC. Okay, what I'm going to do, I'm going to shade the interior. Interior means the inside, so I'm just going to draw lines like this that represent the interior of the angle. Then I'm going to do something similar with angle CBD. I'm going to use a reddish color here. Okay, and I'm going to first trace the angle, angle CBD. Angle CBD. Okay, and then again, I'm going to trace the interior, or shade the interior of angle CBD, which would look like that. And I'm going to go through the three parts here that make up adjacent angles and see if they're true. Do they share a side? Okay, and remember, they have to have a common ray, which was going to be a shared side. And if I look at where my colors are, they touch right here along this ray BC. I can see it's traced in green and it's traced in red. So I'm going to say that the shared side is ray BC. And remember, that's how you draw a ray. Shared vertex point. Okay, the vertex of each angle, it's the letter that's in the middle, it's right here, this point B. The shared vertex is at point B. And now I have to make sure that there are no common interior points. And remember, I traced or shaded the interior with green and then with red. And if you look carefully here, these colors do not overlap. So there are no shared interior points. And so this is a good example of what adjacent angles would look like. Okay, they have a common ray, they have a common vertex point, but the interiors are completely separate. The interiors do not overlap. Let's take a look at the picture that's on the right. So again, we're going to look at angle ABD, and then we're going to look at angle ABC. And again, we're going to go through our three parts here and make sure that none of them, well, that they have a shared side and shared vertex, but no shared interior points. Okay? So let's start this time with angle ABC. Angle ABC is this angle right here. I'm going to trace it in red this time. And again, shade the interior. Okay, and now I'm going to do the same thing with angle ABD. ABD. So I'm going to trace it in green. ABD is this angle right here. And I'm going to shade the interior. Okay, all of that is the interior of angle ABD. So now let's go through. First of all, do the two angles share a side? Well, I see a ray right here. This ray has been shaded twice by green and by red. This is ray BA. So yes, it does share a side. Good. We need it to have a common ray. Ray BA. Does it share a vertex? Well, again, the vertex is the letter that's in the middle of the angle. And again, it's point B, which is right here. So we're 2 for 2. This is good. They share a common ray. They share a common vertex. Now I have to make sure that they don't share interior points. But this is not going to be true this time, okay? If you look right here, this interior of angle ABC has been shaded twice. It was shaded originally in red, but now it's also been shaded in green because it's also part of the interior of angle ABD. And so I can say here that angle ABD overlaps angle ABC. They share interior points. So these angles are not adjacent to each other because one angle is contained completely inside of the other angle. The best way to think about adjacent angles are neighbors, or they're next door to each other, okay? Like in this picture right here. This is the fence that splits the two properties. The neighbors share the fence, okay? But their lawns are completely separate from each other, okay? But over here, all right, angle ABD, all right, that one overtakes angle ABC. Angle ABC is completely inside of this angle, so they are not adjacent to each other. The next angle relationship that we're going to look at are angles that are called complementary angles. Complementary angles are angles whose sum is 90 degrees. Angles whose sum is 90 degrees. And if you remember from last class, an angle that has 90 degrees is called a right angle. So these are going to be angles that if you put them together, they would form a right angle. So in our first example, it says the measure of angle 1, that M means measure, the measure of angle 1 is 57 degrees. The complement would equal how many degrees? Well, if complementary angles have a sum of 90, these two angles are going to have to add up to 90 degrees. So all you would need to do to figure out how much the complement is take 90 and subtract 57. And if you do 90 minus 57, that's going to give you a measure of 33 degrees. So if angle 1 measures 57 degrees, the complement would have to be 33 degrees. Okay, and we can draw a picture of what that would look like. Remember, the two angles add up to 90 degrees, so they make a right angle. So let's draw a right angle. Okay, and we know that this is what a right angle looks like. Okay, but it's not just one angle. It was two different angles that made up the right angle. So I'm going to draw in another ray like this. Okay, and my first angle, angle 1, was 57 degrees. So I'll call this bigger part here 57 degrees. And then the complement was 33 degrees. So the smaller angle in here is 33 degrees. Together, these two angles create a 90-degree angle. So this is what complementary angles might look like. Another example, the measure of angle 1 is 42 degrees. The complement is blank degrees. So again, to figure out the measure of the complement, all we're going to do is take 90 and subtract 42. And if you do 90 minus 42, you get 48. So the complement of a 42-degree angle would be a 48-degree angle. And again, you can just sketch a picture of what that might look like. They form a right angle. Okay, and then we'll draw in another ray. Okay, and we have a 42-degree angle, and the complement, which would have to be a 48-degree angle. The next angle relationship are called supplementary angles. Supplementary angles are angles whose sum is 180 degrees. Angles whose sum is 180 degrees. And remember from last time, a 180-degree angle is called a straight angle. So this is going to be two angles that if you put them together would make a straight line. So in our first example, the measure of angle 1 is 157 degrees. The supplement would have to be blank. Well, again, they have to add up to 180, so all we need to do is 180 minus 157 in order to figure out the supplement. If you do 180 minus 157, you get 23 degrees. Okay, so if angle 1 is 157 degrees, the supplement must be 23 degrees. If the measure of angle 1 is 82 degrees, then the supplement must be blank degrees. So again, all you're going to do is take 180 degrees. You'll subtract off the measure of the first angle, which was 82, and that's going to give you the measure of the supplement, which this time gives us 98 degrees. The supplement of an 82 degree angle is a 98 degree angle. In the next examples, we're going to try to find the measure of the missing angles. In our first picture, we have a 55 degree angle right here, and we have an angle labeled Z, and I want to know how many degrees that Z angle is going to be. So what I'm going to do, I'm going to use my colored pencils again, like I was doing before, and I'm going to trace my angles. I'm going to start by tracing the 55 degree angle. I'll use green to trace that. Here's the 55 degree angle. Okay, and then I'll use my reddish color again to trace angle Z. Angle Z is this angle right here. Okay, and what I'm going to do is look to see if these angles share a ray. Okay, do they have a common ray that was shaded by both colors? And there was a ray right here. This ray was shaded by both colors. And so if you cover that ray up, it's no longer there. You can see all that's left is a straight angle right here. This is a straight angle. And so that means that when you put these two angles together, they form a straight angle of 180 degrees, which means that these two angles are supplementary to each other. Okay, and we said before, supplementary angles are angles whose sum is 180 degrees. So all we need to do in order to get the measure of this angle Z right here is take 180 and subtract off the 55 degree angle. And that'll tell you how much angle Z is. So the measure of angle Z equals 180 minus 55, which in this case is going to be 125 degrees. So this here is a 125 degree angle. In our next picture, we have a 137 degree angle and an angle that's labeled A, and we're trying to figure out the measure of angle A. So again, I'll use my colored pencils. I'll trace the 137 degree angle in green. Okay, and I'll trace angle A in red. There's angle A. Okay, and if I look for a ray that was shaded by both colors, I can see that this ray right here was shaded twice. So if I cover that up, again, all that's left is this straight angle right here. So these two angles make a straight angle of 180 degrees, which means these two angles are called supplementary angles. So to get the measure of angle A, all I have to do is take 180 degrees and subtract off 137 degrees. And when I do that, that's going to give me a value of 43 degrees. Angle A is a 43 degree angle.